Hi teachers, the math coaches and I are glad you're here for part 1 of the Conceptually Understanding and Teaching Number Sense for 2nd and 3rd grade PD. In this session we will focus on fractions, so let's get started. First, just going through the purpose of the professional development today. Number 1, to see the benefit of conceptual understanding. We will be talking more about conceptual understanding and what that actually means on the next slide, but hopefully today you will begin to see how having a conceptual understanding of math concepts is very beneficial and also necessary in order to have math success. The next one is to launch and explore conceptual teaching beginning with your grade level's number sense strand. So we're going to look at something called the vertical articulation. The IDOE, or the Indiana Department of Education, offers some great resources that help to lay out the progression of standards. So we're going to be using those documents today as we work to explore the idea of conceptual teaching. We're also going to talk about some practical application of these standards in your own classroom. Of course, we know that what all teachers really want to see is how concepts can look in their own classroom. So we will be working through some of those examples and showing you some teaching techniques and activities that you can use in your own room during our time today. So first we are going to focus on the idea of procedural versus conceptual. So on the left side you're going to see a green box that talks a little bit about what procedural knowledge is. So if someone is very procedurally based, there are going to be a lot of steps to follow. So there's some sort of an action sequence that students need to follow. You will see a lot of facts and skills and algorithms for procedural knowledge. Procedural knowledge involves memorization without requiring understanding. So you would have students that can do the math, yet they lack an understanding of what it is that they just did. Also, they know how to get an answer and complete certain steps, but they do not have an ability to explain the process or why it is that they did those specific steps in that order. On the right side, you can see a yellow box that talks about conceptual knowledge, and this is what we really want to focus our teaching and our understanding on. So conceptual knowledge creates an understanding of how concepts are connected. There is a lot of research about how math, instead of viewing it as isolated pillars and different concepts and skills, seeing how they're all connected can be very beneficial. Also, students realize and use relationships between ideas with conceptual knowledge. And lastly, it allows students, and of course us as teachers, to learn why something happens in a particular way. So with the procedural knowledge, we were saying that students can get the answer, but they don't really understand the process or why they went about those steps. With conceptual knowledge, they're going to be able to explain why they did the things they did and how it ended up working out. So most of us were not really taught in a conceptual way. It's a new idea to us as educators, but once we begin to understand the power of conceptual teaching, it really does become a mindset. So Jo Boaler is a professor at Stanford University, and she's the creator of U Cubed, which is actually a wonderful resource for math instruction. In one of her videos, which you can find in the portal, she explains the good and bad of mathematics education and how it applies to the real world. So I would highly suggest, once you're done with this PD video, heading back to the portal and finding that video from Jo Boaler to hear a little bit more about her research behind conceptual understanding. So this is the vertical articulation from the IDOE's website, and it shows how standards progress from kindergarten to 1st grade to 2nd grade. And then there is another vertical articulation to show the progression of standards from 3rd grade to 4th grade to 5th grade. So we've actually taken both of those documents and snipped images. So you will notice that since this presentation is focused on 2nd and 3rd grade, we needed to have 2nd grades from the vertical articulation, and we also needed to have 3rd grades from the vertical articulation. However, you will notice that these standards do not line up because they're actually two separate documents. So I want you to notice on this slide that we have some standards circled in red. So these 3 standards from 3rd grade circled in red. And the first time fraction notation is introduced is actually in 3rd grade. Before that, students are going to be exposed to the idea of halves, thirds, and fourths. However, when they're exposed to them prior to 3rd grade, they're working in their geometry stand. So solely working with the idea of dividing shapes into equal parts. 3rd grade is the very first time that they're going to be introduced to that fraction notation idea. So the goal in 3rd grade is not to see a fraction as a numerator and a denominator, or that the numerator goes on top and the denominator is on the bottom. But instead, we want 3rd graders to start to understand that fractions are numbers. They represent quantities and they have values. So as you look at the image on your screen, you can see that with fractions, iterating or counting by a set amount is a really important skill. So looking at the number line, you can see how just like all numbers, students can count by a fractional amount. So on the number line, we can see that we can count 1/4, 2/4, 3/4, 4/4. And they can see how each time they're counting, they're adding 1/4 each time. They can also see that a fraction such as 3/4 is made up of 3 1/4 pieces. Using a number line also makes it easy and clear to see that a fraction such as 3/4 is comprised of 1/4 pieces. Just remember that in 3rd grade, when you are working with fractions, the denominators are limited to the numbers 2, 3, 4, 6, and 8. So any fractions that they're working with should only have those 5 different denominators. Students should also work with 2 different representations of fractions, and you see those 2 different representations here. So notice that both of those images are representing the fraction 3/4. However, they are using different types of models to do so. So on the left side of the screen, there is an area model. So an area model is when you have one item or shape and you divide it into equal parts. So here we have one square that is divided into 4 equal size squares. To show 3/4, 3 of those 4 squares are colored yellow. So that's an area model showing 3/4. On the right side, we have a measurement model. A measurement model is when you are using a linear representation to model. So here we have a number line that is divided into fractional increments, each representing 1/4. In order to show 3/4, there is a line at the top spanning the length of 3 1/4 increments, which means this line would total 3/4. We're going to talk a little bit more about one of those representations being area models. So on the screen, you can see some of the various ways you can represent fractions, all using an area model to do so. So some examples being paper folding. I'm taking one whole and I'm dividing it into equal parts. Pattern blocks are another area model representation. Fraction tiles or fraction circles, and even a geoboard. So in order to model the fraction 4/6 using an area model, students would first need to divide their whole into 6 equal parts. So this could be done by folding a sheet of paper into thirds and then folding the thirds in half. Obviously, that would be a skill that students would need experience with. But once they folded their paper into thirds and then folded their thirds in half, they would create 6 equal parts. Once the students had folded their 6 equal parts, they could represent 4 of the parts by coloring 4 of the boxes or putting an X in 4 of the boxes to then represent 4/6 using an area model. So here's just an example of an area model representing the number 2/3. So over here, the yellow is just showing us what our whole would be, which is an important idea for students to understand, that we have to know what our whole is to then show 2/3, because 2 of those blue boxes each represent 1/3, because 3 of them would cover our whole. So 2 of them is representing 2/3. Next, we're going to look a little bit closer at measurement models. So remember that measurement models are when you are representing in a linear way. Here are some different measurement models. So again, we have paper folding. So you will notice that paper folding was an area model as well. So paper folding becomes a measurement model when the whole is long and thin, making it only possible to fold them in one direction. So instead of being able to fold it horizontally and vertically, I can only fold it in that linear way. We also have number lines as a measurement model to represent fractions, and Cuisenaire rods. So if we wanted to represent the fraction 4/6 using a measurement model, such as a number line, students would, again, need to divide their whole into 6 equal parts. So just like with the paper folding, that could be done by dividing their number line into 3 1/3 increments, then dividing each of their 1/3 sections in half, creating increments representing 1/6. Students could then draw a line on their number line spanning to the 4/6 marker, therefore showing a line that would measure 4/6 in length. So here is a measurement model to represent the number 5/8. So again, really important, we have our brown Cuisenaire rod showing what our whole would be. And then we found that 8 of these white blocks would fill our whole. So by having 8 of them, that means each one represents 1/8. So 5 of them would represent 5/8 of our whole, or a yellow bar or a yellow Cuisenaire rod is the same length as 5 of our white rods. So the yellow rod could also represent 5/8. This is going to be the stopping point for part 1 of conceptually understanding and teaching number sense for 2nd and 3rd grade focused on fractions. So you will find part 2 in the portal. Thank you.